The circuit contains a battery of EMF 12 volts and negligible resistance. What is the potential difference across the 25 ohm resistor? Well, we know that we have a total resistance here of 40 ohms. So I can work out the current. I is equal to V over R from my formula over here. And so that's going to equal 12 divided by 40, and that equals about 0.3 amps. So we have a current of 0.3 amps, and it goes through here. So the potential difference across here, we would work out the V, we would work out as I times R. So that would equal 0.3 times 25. So it would be 0.7, it would be 7.5 volts. If I did this across here just to make a point, this one would be V is equal to 0.3 times 15, and that would be the balance of that. So that would be 4.5 volts. 4.5 plus your 7.5 is giving you a 12. So the answer for that is D. Alright, looking at question 9, it says the diagram below shows two stationary points plus 2Q and minus Q. At which point is the electric field strength the greatest? Now if I just draw electric field lines, we'd have electric field lines that would look something like this. Would be going from positive to negative. It would be like this. And then we would have like this, something like this. And here we would have it radiating outwards like this. There would be more field lines on this side because this 2Q. But as we can see here, the point at the point B, let me do this in a different color, would have a force because this is over here, because this is negative and this is positive. If we put a positive test charge in here, we would have a force due to the 2Q there, and we would also have a force due to the minus Q attracting there, and so you would have an addition of the forces taking place, and so you would have a strengthening. If we take this one over here, for instance, you would have your force from your 2Q in that direction, but it will be less because it's a further distance away. But you would also have a force in that direction due to the minus Q. So there would be a cancelling out of force, and you would have the same thing happening in this case over here. So B would definitely be the strongest there for that case. Question 10. The diagram below represents four long straight wires perpendicular to the plane of the paper. The magnitude of the direct current in each wire is the same, so we have the same I in each case. Wires with a plus, with a cross, have current plane of paper, and wires with a dot have current out of the plane of the paper. This doesn't seem to make much sense, does it? Point 1 is the same distance from, must be point P, as the same distance from each wire. Which arrow shows the direction of the magnetic field at P? Okay, so we've got this over here. Now what I'm going to do is I'm just going to, I don't know how good my diagram is going to be, but I'm going to try and draw a circle around each one of these. I'll do the ones in black, something like this, for those two, and then these over here would, not great diagrams, but anyway, I think you'll see what. So we've got that case over there, something like that. Okay, now let's take for this one over here. So the current is going into the board, so we put with the right hand, we put our thumb in the direction of the current going in. Can we see that we're going to get a magnetic field like that? So we'll get, at this point over P, would have the tangent, the force on that would be the tangent at that point. So we have a force there. On this side over here, we put our thumb in the direction of the current that's into the board. We're going to have, it's going to be counterclockwise again like that, so we'd have a force something like that. That will be for that one. Then for the bottom ones over here, now here we're going out of the board, so our thumb will be sticking out of the board, and so we're going to get a current, a magnetic field like that, and so that would create a magnetic field like that. And for this one also, thumb out, we would get this direction, it will be anti-clockwise, and at point P it will be something like that. So we see we have that. So those would combine to give you a force in the direction of D. So D would be the correct one. Question 11 is the definition for an ampere. Two long parallel wires are separated from a distance 1 meter. The current in each wire is 1 amp. Which of the following is the force on 1 meter length of wire? It's this over here. 2 times 10 to the minus 7 newtons. This is your definition of an ampere.